Assalamu alaikum everyone, welcome to Final Touch Academy. Today we have got this paper of chemistry, paper 2, Pearson Edexcel IGCSE 9-1. This exam was conducted in the major examination series of 2024. So, moving on to the first question, it tells us use the periodic table to answer these questions. So using the periodic table will really help us. The periodic table is given at the start of the paper. Give the name of the element with atomic number 16, that would be sulfur. Give the name of the element with relative atomic mass 9. So if we check the periodic table, that would be beryllium. For the third one, give the name of the element in group 3 and period 2. That would be boron. If we check the periodic table, so it was boron, group 2, period 3. Number 4, it tells us give the electronic configuration of an atom of silicon. So we know silicon has an atomic number of 14. So this would be 2, 8, and 4. Part B tells us to explain in terms of electronic configuration why sodium is more reactive than lithium. So we know sodium has a larger atomic radius. So we can say sodium has a larger atomic radius, therefore less attraction between the nucleus and outermost electrons. So lastly we can say, so the outermost electrons is easily lost. So that's your answer for question 1, part B. Coming on to question 2, it tells us structures made of iron can rust. Name 2 substances that cause iron to rust. So we know one of them is oxygen, the other one is water. State a barrier method that prevents rusting. There are multiple answers for this. You can mention about painting, galvanizing, electroplating. There are some other answers that are accepted as well. Part B tells us explain how sacrificial protection prevents the rusting of iron. So when sacrificial protection is done, we use a more reactive metal to coat the iron. The more reactive metal will react instead of iron. That's your answer for question 2, part B. Coming on to question 3, it is about a fractionating column is given. The diagram shows the separation of crude oil into fractions. Give the name of fraction A and the name of fraction F. So obviously at the top we have refinery gases, and at the bottom we have bitumen. Refinery gases is the most lightest one and bitumen is the heaviest one, so therefore it is at the bottom. Part B1 tells us one of the fractions is kerosene. Give one use of kerosene. So definitely we use kerosene for aircraft fuel. B2 tells us describe how kerosene can be obtained from crude oil. So to obtain kerosene from crude oil is heated at first. Next, the vapor produced passes up the column. You can write fractionating column. The kerosene is removed as it condenses. So that's how we obtain kerosene from crude oil. Moving on to C1, catalytic cracking is a process used to break down fractions containing long chain molecules. Give the name of the catalyst and the temperature used for catalytic cracking. So catalyst we use for catalytic cracking is silica. The temperature should be between 600 to 700 degrees Celsius. Explain why catalytic cracking is useful. So first off, catalytic cracking is useful to provide larger fractions. So the first point we can write is if there is less demand for larger fractions, at that point we say alkenes are produced which are needed to make polymers. So therefore smaller fractions are needed for petrol. So that's your answer for why catalytic cracking is useful. So usually it is useful when there is a lesser demand for larger fractions. Therefore, when any larger hydrocarbon undergoes cracking, smaller products are being made, such as alkenes, which are then used to make polymers, or some smaller fractions are also needed for petrol. Moving on to the fourth question, the table shows the maximum mass of potassium nitrate and the maximum mass of sodium nitrate that dissolves in 25 cm cube of water at different temperatures. Plot the data for potassium nitrate and for sodium nitrate on the grid. So we have to draw this curve. So if we look at the values, we will get this curve. So let's point out the points we have on the graph at 10 degrees Celsius, at 10 degrees Celsius. The mass of potassium nitrate is 5. So 10 degrees Celsius, it is 5. At 25, it's 10. 25, it's 10. And at 40, it is 16. 40, it is 16, right above here. At 60 degrees Celsius, 28. This is 26, 27, 28. And at 75 degrees Celsius, they gave us 39. 75. 39 should be here. So we'll use another. We have to plot the mass of sodium nitrate as well. At 10, it is 21. So 21 should be here. At 25, it's 23. 23. At 40, it's 26. At 60, it's 31. At 75, it's 35. So that's our answer for 4A1. So now in 4A2, they told us to draw and label a curve of best fit for potassium nitrate and sodium nitrate. So if we were to join this curve, it would look something like this. And if we were to connect these lines, it would start from here. Make sure you join all those points. So this would be the answer for 4A. They told us to find the graph that shows the temperature at which maximum was dissolved in the same for each solute. Determine this temperature. So if we look into the graph, at approximately this point is where the graph intersects with each other, and this is close to somewhere at 69 degrees Celsius. So we can write it as 69 degree Celsius. There should be a range of values that would be accepted for this. So moving on to the next one, use your graph to calculate the solubility in grams per 100 grams of water of sodium nitrate at 30 degree Celsius. So if we check for the sodium nitrate graph, which is the blue one, at 30 degrees Celsius, it's here. So if we were to extrapolate this line, we end up at somewhere between 24 grams. And they told us to calculate the solubility in grams per 100 grams of water of sodium nitrate. So what we can do is, we have 24. We have 24 in 100 grams of water. So sorry, 24 grams in 1 grams. So if it was the other way around, if it was 100, so it would have been 4 times more. So in that sense, 4 into 24 grams is for 100 grams of water. So 4 into 24, we get 96 grams for 100 grams of water. So the answer should be 96 grams. Moving on to D. 25 cm cube of a saturated solution of potassium nitrate is cooled from 50 degrees Celsius to 20 degrees Celsius. Use your graph to determine the mass in grams of potassium nitrate that crystallizes. So we need to look at the mass we have at 50. So it's around probably 21, and at 20 it's at 6. So we have our values. 21 minus 6, we end up with 15. So it will be 15 grams. There is a range of values accepted for this answer depending on the curve you draw. Moving on to the question number 5. Methanol CH3OH is the first member of the homologous series of alcohols. Give two characteristics of a homologous series. So for a homologous series, it has the same general formula. Secondly, they have the same functional group. That's your answer for question 5, part A. Moving on to part B. Methanol is heated with potassium dichromate 6 and one other reagent. The methanol is oxidized to methanoic acid. Give the formula of the other reagent. So the other reagent we use to oxidize methanol is H2SO4, sulfuric acid. Give the color change that occurs during the reaction from, we know, changes color from orange to green. Draw the displayed formula of methanol and for methanoic acid in the boxes. So methanol should be this one. And methanoic acid should be so that's your answer. Methanol reacts with methanoic acid to form an ester. Complete the equation for this reaction. So the ester that forms will be HCOOCH3. As we know, we take the first part from the carboxylic acid, then we react it with the first part of the alcohol, and the other product will be water. What is the name of this ester? So we have here butyl ethanoate. So this is for this one. Sorry, this one. So the butyl comes from this one, 4 carbons, and ethanoate for this 2 carbons. Deduce the molecular formula of this ester. The molecular formula should be C6H12O2. Moving on to question number 6. A scientist reacts lead 2 nitrate solution with sodium bromide solution. This is the equation for the reaction. So describe how the scientist could obtain a pure dry sample of lead 2 bromide from the reaction mixture. So the first part is to filter the mixture, then wash the precipitate that is being formed with distilled water, and then which can just write about dry the precipitate in a dry oven or warm oven. Moving on to B1, the scientist reacts an excess of lead to nitrate solution with 25 cm cube sodium bromide solution of concentration 2 mole per dm cube. Show that the amount of sodium bromide used is this. Simple. Mole is equals to concentration into volume. So concentration is 2. Volume should be converted into dm cube, so divided by 1000. So we end up with 0.05 mole. So the answer they wanted is what we got. Show that the maximum theoretical mass of lead to bromide is approximately 9 grams. So if we move into the equation, we calculated the amount of, the mole of sodium bromide. So if it has a mole of 0.05, the mole of lead to bromide will be halved. So moles of lead to bromide should be half. So the answer should be 0.025 mole. And they told us to calculate the mass. So for mass of lead to bromide, we have 0.025 into MR is given 367. We get 9.175 grams. That's your answer for part 2. Moving on to C, the scientist electrolyzes molten lead 2 bromide using this apparatus. Explain why lead 2 bromide needs to be molten rather than solid for electrolysis to occur. So obviously when it is in solid, the ions are fixed in the lattice structure they have. So that should be enough. So there are no ions that are free to move. So lastly we can say, therefore, when molten, the ions are free to move, so they can carry a charge. So that's your answer for part C1. Moving on to C2, the electrolyte is at a temperature of 400 degrees Celsius. Explain a suitable material for the electrodes. So usually for electrodes we use graphite because it has a high melting temperature So moving on to C3, give the half equation that occurs at the negative electrode. So at the negative electrode, we will have the cation, which is lead 2 ion, which is Pb2 plus 2 electrons to Pb atom. Bromine forms at the positive electrode. This is the half equation for the reaction of the positive electrode. State what is observed at the positive electrode. Since there is bromine, brown gas is seen as bromine gas is being produced. State why the half equation represents an oxidation reaction because the bromide ion loses electrons. That's your answer for question 6. Moving on to question 7. It is about a question regarding hydrogen chloride. Hydrogen chloride is a covalent compound. State in terms of electrostatic attraction what is meant by covalent bond. So we can simply say a covalent bond forms when there is an electrostatic attraction between nuclei as electrons are shared as pairs. That's your answer for 7A. Moving on to 7B, tells us when hydrogen chloride gas is dissolved in an organic solvent, the hydrogen chloride remains a covalent molecule. When hydrogen chloride gas is dissolved in water, ions are formed. Explain what happens when dry blue litmus paper is dipped into separate samples of each solution. So when it is put in the organic solvent, we know litmus paper stays blue. When it is dissolved in water, so why does it stay blue? Because there are no H plus ions formed. Because in acidic solution, the hydrogen chloride gas does not dissolve. Sorry, in the organic solvent, it does not dissolve. Whereas in the aqueous solution, as in the water, litmus paper turns red as H plus ions are formed, or you can say HCl forms when reacting with water. That's your answer for 7B. Moving on to 7C, it tells us in the presence of ultraviolet radiation, hydrogen reacts with chlorine to form hydrogen chloride. So this is a question based on enthalpy. So it tells us to calculate the enthalpy change for the reaction, include a sign. So we know del H is equals to total energy in reactants minus total energy in products, or the total bond energy. So the total energy in reactants should be 436 plus 242 minus, there's 2 HCl, so we just multiply 2 into 431, so we get 678 minus 862. The answer comes as minus 184 kilojoules per mole. That's a simple question. So moving on to the last question for this paper. Draw a reaction profile for the reaction. Label the reactants, the products, and the activation energy. So we had a reaction which was exothermic. So if we just draw the lines for the reactants and the products, this would be something like this. What were the reactants here? H2 plus HCl, and the product was 2HCl. So if we move into the question, we can just write H2 gas plus Cl2 gas, and we put an arrow. The del H we found was minus 184 kilojoules per mole, and we had 2 HCl as the product. They told us to label the reactants, the products is done, the del H is done. Now we just need to label the activation energy. So if we start from here, the activation energy should be something like this. So if we draw an arrow from here, so this arrow is our activation energy. So that's your answer for the last question. Hope you understood the whole solution of this paper. Thank you for tuning in to the Final Touch Academy.